Hello friends, in this video I am discussing Rolle's theorem. This is the sixth video in the differential calculus. Rolle's theorem, let f of x be defined in a closed interval a comma b such that it satisfies three conditions. First condition is f of x is continuous in closed interval a comma b, and second condition is f of x is differentiable in open interval a comma b, and third condition is f of a is equal to f of b. Then there exists at least one value c belongs to open interval a comma b such that f dash of c is 0. If uh, if all these conditions are satisfied, then the Rolle's theorem is verified. Now we have to see some examples related to Rolle's theorem. Example 1 is verify Rolle's theorem for the function f of x is equal to x square minus 6x plus 8 in closed interval 2 comma 4. Solution for this question is f of x is equal to x square minus 6x plus 8 is a polynomial of degree 2. You have to check the conditions of three conditions of Rolle's theorem. The first condition is f of x is continuous in closed interval 2 comma 4, and second condition is you have to differentiate this with respect to x. We get f dash of x is equal to 2x minus 6. Therefore f of x is differentiable in open interval 2 comma 4. The third condition is f of 2 is equal to f of 2 is in place of x we replaced in place of x in this equation we replaced 2. We get 4 minus 12 plus 8 is 0. In place of x we replaced 4. We get 0. Therefore f of x satisfies all three conditions of Rolle's theorem. Then there exists at least one value c belongs to open interval 2 comma 4 such that f dash of c is equal to 0. Therefore um, this in place of x we replaced c. We get 2c minus 6. 2c minus 6 equal to 0. 2c is equal to 6. We solving this we get c value is 3. Therefore 3 is belongs to this interval. Hence Rolle's theorem is verified. Now we see the second example for Rolle's theorem. Verify Rolle's theorem for the function f of x is equal to e power of x sin x in closed interval 0 comma pi. The solution for this question is f of x is equal to e power of x sin x. Now we have to verify the three conditions of Rolle's theorem. The first condition is f of x and sin x both are continuous for every value of x. Their product e power of x sin x is also continuous for every value of x, and f of x is continuous in the closed interval 0 comma pi. The second condition is now we have to differentiate this with respect to x. Now we have to applying product rule here. Differentiation of first function is as it is, and differentiation of second function is cos x plus second function is as it is, and differentiation of first function e4 of x, then f dash of x is equal to take the e4 of x common, e4 of x sin x plus cos x. Therefore f of x is differentiable in open interval 0 comma 5. The third condition is in place of x we replaced 0. In this equation we get e4 of 0 sin 0. Sin 0 value is 0. Then f of 0 is 0. And in place of x we replaced pi. In this equation we get e pi sin pi, and we know that sin pi value is 0. Therefore f of 0 equal to f of pi. Therefore, three conditions of Rolle's theorem is verified. Three conditions of the Rolle's theorem is satisfied. Then there exists at least one value c belongs to open interval 0 comma pi such that f dash of c is equal to 0. Therefore, this equation becomes in place of x we replaced c. We get e power of c sin c plus cos c, that is e power of c sin c plus cos c is equal to 0. Sin c plus cos c is equal to 0, and dividing cos c on both sides we get sin c by cos c plus 1 is equal to 0. Sin c by cos c value is tan c, and one is here we dividing cos c on both sides, cos c cos c cos c. See, this is cancelled, and sin c by cos c is tan c, and this one is goes to right hand side. Then tan c is equal to minus 1, and c value is 3 pi by 4. Therefore, c is equal to 3 pi by 4 belongs to open interval 0 comma pi. Therefore, Rolle's theorem is verified. Thanks for watching.